This standard is about solving systems algebraically. In the last standard, we learned how to solve systems by drawing a graph and seeing where they intersect, but sometimes that's awkward. Sometimes you have fractions, sometimes they intersect at weird places. So you can always get an answer if you solve them using algebra. And we're going to do two ways. The first way is substitution, and the second way is combination, which is sometimes called elimination. So for substitution, first of all, you're going to solve one of the equations for one of the variables, and it's better if you pick a variable that has a coefficient of 1. Then you're going to substitute that solved equation into the other equation, and then you'll go ahead and solve that for one of the variables. Then put your answer back into the equation from step 1 to find the other variable. Wow, that sounds like a lot of stuff. So let's give it a go and see if we can break down the steps. First of all, I'm going to solve one of the equations for one of the variables. So, looking in the first equation, I have x minus y. X and y both have a coefficient of 1, so either one of those would be a good choice. In the second equation, I have 2x plus y equals 19, so that y would be a good choice, but I wouldn't solve for x in the second equation, because then I would get a fraction when I would divide everything through by 2. So I'm just going to solve the first equation for x, because that's the one on the left, and that looks good to me. So x minus y equals 11. So to solve for x, I'm going to add y to each side, and I get x equals 11 plus y. So the second step says to substitute that back into the other equation. So what I've just done is I showed that x is the same thing as this thing 11 plus y. So I'm going to look at the second equation, and everywhere I see an x, I'm going to substitute in an 11 plus y. So I'm going to have 2 times 11 plus y equals 19. So there's that 11 plus y that I put in place of this x over here. Now I'm going to do step 3, which is solve for one variable. So I'll go ahead and solve this equation for y. That gives me 22 plus 2y plus y equals 19. Combine like terms, 22 plus 3y equals 19. Subtract 22 from each side. So I get 3y equals negative 3. Divide by 3, divide by 3. Y equals negative 1. So the last step says put your answer back into the equation from step 1. That's this equation over here. So I'm going to replace that y with negative 1. So x equals 11 plus negative 1. X equals 10. So I'm going to write this answer as an ordered pair. I have 10 for x and negative 1 for y. So let's try another one. This one looks a little different. The x's and y's aren't arranged right on top of each other. But actually this one's easier, because what I want to do is substitute one of the equations into the other equation. But this equation already has y by itself. So I already know y is the same as that. So I can move right on to step 2, which says substitute the solved equation into the other equation. So I'm going to say 10x equals 7, and in place of y, I'm going to put negative 5x plus 9. So that's the thing I substituted in. Minus 18. So now I'm just going to go ahead and solve that. So 10x equals negative 35x plus 63 minus 18. So combine like terms, 10x equals negative 35x. All right, 63 minus 18. Let's just do that over here on the side. 63 minus 18. So cross out the 6, make it a 5. So 5, 45. So plus 45. And then I'm going to add 35x to each side. This is looking good. So 45x equals 45. Divide each side by 45. And x equals 1. So for the last step, you replace that into the revised equation, but I didn't do a whole lot of revising actually. So I'm just going to put it right back into this equation over here. So y equals negative 5 times x, which is 1, plus 9. Y equals negative 5 plus 9. Y equals 4. So the solution to this system of equations is 1, 4, written as an ordered pair. The second way to solve equations using algebra is to combine them together. So there's 5 steps. First, you arrange the like terms in columns. Then you multiply one or both of the equations by a number that makes one of the pairs of variable terms cancel. There's a sentence, but it's pretty easy to do once you get used to it. Then you add the equations together. After you add the equations together, you have an equation you can solve for one of the variables. And then you put that answer into either one of your original equations to solve for the second variable. So first of all, let's arrange the like terms in columns. So I'm going to subtract 3y from each side in this second equation to get x minus 3y equals negative 6. And then that first equation, negative 4x plus 9y equals 9. All right, step 1. Now, what I want to do is add these two equations together and have either the x or the y cancel out. If I add x and negative 4x, I get negative 3x, which doesn't cancel. If I add negative 3y and 9y, I get 6y, which doesn't cancel. But if I multiply, and there's two choices, but I'm going to pick the one I like better. If I was to multiply this second equation by 3, negative 3y times 3 is going to be negative 9y, and negative 9y is going to cancel out with 9y, and I'm going to have finished step 2. I could have also canceled out the x's. I just picked y because I was multiplying by a smaller number, 3, instead of the 4 I would have had to do with the x. So when I multiply through, I get 3x minus 9y equals negative 18. And then let's do step 3, which is add the equations together. So I'll get negative x, these guys cancel out like they're supposed to, equals negative 9. So that means x equals positive 9. And then I'm going to substitute this into one of the original equations. I guess I'll go with the second one because the numbers look smaller. So x equals 3y minus 6. In place of x, I'm going to put 9 equals 3y minus 6. I'm going to add 6 to each side. 15 equals 3y. Divide by 3, divide by 3. Y equals 5. So the answer to this system is 9, 5. Sometimes the equations are a little more complicated and you have to multiply both equations by a number to make it work. So in this equation I'm going to cancel out the x's. I canceled out the y's last time. I want to do it different. So in order to get 3 and 5 to cancel out, I'm going to turn both of them into 15. So I'm going to multiply this top equation by 5. That's going to give me 15. And in order to make them cancel out, I need a positive one and a negative one. So I'm actually going to multiply this second equation by negative 3. So that's going to give me 15x from the top equation and negative 15x from the bottom equation. And then when I add, they'll cancel out and life will be good. So 15x from the first equation minus 10y equals 10. And on the bottom equation, I have negative 15x plus 15y equals negative 30. So we'll add those two together. These guys cancel out. So 5y equals negative 20. Divide by 5. And y equals negative 4. So we'll put that back into one of these equations. I guess I'll go with the top one because the numbers are a little bit smaller. 3x minus 2 times negative 4, I put negative 4 in place of y, equals 2. So 3x plus 8 equals 2. Subtract 8 from each side. 3x equals negative 6. Divide by 3, divide by 3. X equals negative 2. So the answer is negative 2, comma, negative 4.